Hi everyone and welcome. I'm Pooja, Brand and Communication Manager at TestMu AI, and I'll be your host for this session at TestMu Conference. Good to have you all with us. Quick ask before we begin. Post your takeaways on LinkedIn and Twitter, tag us and use hashtag TestMu Conference so the rest of the community can follow the conversation. And if you have any question during the sessions or after the session, feel free to drop them in the Q&A box. We will take the question towards the end of the session. Now, to today's topic for the session, almost every product has a chat box attached to it. For fewer teams can say with confidence that their gives correct answers, stay civil with users and won't explain how to do something dangerous. And it's hard to test by design. It returns a wall of text and never the same wall twice. So the question on the table is how you put a real test around an LLM response instead of reading a few outputs and hoping. Today's speaker for the session, Gil Zilberfeld, has been writing code and building software for over 25 years, starting on a Sinclair ZX81, and today runs TestinGil, where he trains and consults with R&D and Q&A teams on building better software from the inside out. He is a frequent international conference speaker on TDD, clean code and web automation, currently focused on engineering led frameworks to improve the quality and resilience of AI powered systems. Please join me in welcoming Gil. Gil, over to you.
Thank you. Thank you, Pooja. I'll share my screen. Yeah, cool. We want to see this. Hi, everyone. Welcome to TestMu. I'm a repeating offender here. So, not my first time. And this is something that I'm becoming more and more invested in. And it's basically talking about the quality of how to test chatbot. But as you'll see from my examples, it's a little bit more than that. So this is my robot. I trust it completely, and I hope you trust yours as well. So before we start, a bit about me. So Pooja introduced me. I'm a trainer and a consultant, and I help people who wants to write, develop, and test better software. And today we're going to talk about the testing part. Um, so every one of us, I think, most of us, I didn't really meet someone in the last 2 years that hasn't even tried talking to a chatbot. And you ask it something, and you ask something else, maybe it's a whole chat, and you're thinking, well, is it telling me the truth? And there's a certain series of things that we do that kind of filters the thing. So we look at the answers. I'll give you an example. I heard a couple of weeks ago that people started testing chatbots. They were asking them very simple questions like, which are the most populated cities in the world, five most populated. And every time they got a different answer, which, as we know, happens a lot. And you have you can check if these are the 5 things. Okay, this changes over time. If they appear in the right order, if they appear not in the right order, is it still true? So if we are in charge of testing applications that use an LLM as an origin of something, we need a way to first check if what it's telling us is true or not. And remember 2 years ago, we were talking about hallucinations and stuff like that. We still do that, but it's not less because the models were getting better. We're getting better and handling them. But we have a superpower, you and I. When you're looking at an answer of chatbot, what your brain's doing is doing a couple of things. It looks at the answer and says, I can say this part looks okay. This is a bit dodgy, I don't trust it, so I'll ignore it. And maybe my follow-up question, I'm talking to a chatbot, will direct it in the right direction. Sometimes it works, sometimes it doesn't. So our brains, this is our superpower, kind of filters things out, which helps us as users, which is okay. But if we're testing a chatbot, we've got different ideas of different set of standards we want to apply. We want the chatbot, or our agent, as we'll see today, to tell us the rightest, the truest answers that we can, because this applies to the customers again. If you're using one, you'd like better answers. And like I said, we kind of already adapted to a way of filtering things out. Unfortunately, agents who call the LLM and do something with the responses before they return it to us, make decisions, apply tools, whatever, they don't have this filter inside. So when we're testing a system that either a chatbot or something that is relying on an external brain, we'd like to know or evaluate how good it is. In order to say at the end, like we're testers, we know that at the end somebody will ask us, can we release this? Is this ready? Is this good enough? And we want the answer to that. So we need a way to qualify that. So I'm going to show you different techniques today of how to do this. It looks like a funnel. It's sort of, could be a funnel. Because if you think about this, you kind of want to throw your testing or your test results through like a sieve and see what's going in. Every time a sieve is getting finer and finer, and the more things go through different steps, the better the results are. And if before we had something like an automated test that tells you like red, green, like green means everything's okay, or like 100 greens means everything okay, this is no longer the case, and we need to get to adapt to this. It's not something that is going away. What I'm going to show you today is an agent I built. And this is a test planning agent. So it's like this. It doesn't have reading. We're going to talk about these parts, but a client could be like a chat interface where you can say, give me a plan for this API. And this is the architecture. It's built in Python, so we have like a server and the logic of the agent, which basically does nothing. I'll show you in a minute. And it sends a prompt to the LLM, give me a plan for this, and it kind of returns the results to the client. And we're looking at, say, okay, is this working? Yeah, okay, so I'm going to jump into my PyCharm, and this is what I'm going to work with. So you can take a look at the repo on GitHub. This is the prompt that's being sent to the LLM. I'm using here Gemini, I think. You're an expert, senior QA automation engineer, tasked with creating a test plan for a new API endpoint. Based on the API endpoint, plan must include the following sections: API explanation, happy path, unhappy path, edge cases, and this is where things are embedded. So this is the prompt. My agent is a class that runs inside a controller, and basically, don't need breakpoints. What it does, it calls generic platform endpoint. There's a code here that wraps things, embeds the input in the prompt, and sends it to here, sends it to the LLM, gets something back, and even formats it. So, so there's code running before there's code running after, and we want to see that everything works together as we want. So if you actually run it, prepare things before. You'll get something like this. Okay, so this is a formatted part. Markdown, you see a happy path and a happy path, stuff like that. Okay, so how do we know if this is what the user expects? This is the question that we're trying to answer. Okay, so it all starts with a plan, obviously. And when you think about the test plan, we're thinking about everything, right? Like this is like a system test, but what I did here in the prompt, because I wanted to generate a test plan, not just by myself, in the real world, you will review what it got you, but also do something with yourself. There's a class, I told it how it's built. It's a class that calls it. There's the prompt that I showed you. The controller that runs everything. And based on this, generated list cases, black box, like these are API tests, agent unit tests, white box, you know how it's built. Write test for that. Oh, no, not write test for that. Suggest test cases for that. Performance, reliability, everything that you can think of, and we'll get to this point over and over. Whatever you can ask, it will probably get something better. And we're at the point of actually creating a test plan. So how do we test this? Well, ask the robot. A different robot, but yeah, it gives you like a list, control API tests, happy paths, all kind of invalid JSON, malformed, blah, blah, blah. And for unit tests, what you can do, all kinds of things. The more this is something I didn't do here. If you're running like a code agent or inside a code agent like Cloud Code or Codex or whatever, or you're running it inside an IDE and it has access to the code, it can create better tests. Now, what we're going to start to do is add more and more layers of tests and quality to make sure to define what really is working. So these things tell us, well, this works okay. But let me show you something. Where's the thing here? Like these are the system tests for the API. So yeah, if it returns this has a post. If I send it a get or a put, it returns a 405. Talked about malformed JSON. Yeah, these are error handlings, and these are like things that you'd like to make sure that happens or the code behaves correctly. This doesn't tell you anything about the response itself. Okay, so what you think about this? If you're trying to talk about quality, this starts to be like relevance. So if a post for an user's API, generated plan should focus on creating users, blah, blah, blah. It doesn't have any context, because I haven't given it any context about what's going on here in real life, because my agent doesn't know anything about what I'm going to send it as an input. I'm not saying this is going to be accepting a post users or get product ID. So this is part of thinking broadly, okay? And this is done by a genie, like my robot, Gemini at this point. And but I've already given examples. And this, I review this, I say this is okay, this makes sense. If I provide the details for get product ID, a plan should include positive test, negative test, and security authorization. And if it's not okay, I will edit that, okay, and do another round, and create a test plan that at least covers what I need. And return to the point, we need to say upfront or as we go into this, and I'll show you examples, what we need, because we don't always know at the beginning what we want. We can't at the beginning most of the time tell anyone what correct is. We need to define it, and usually it's an iterative process, like software, right? We learn on the way. Okay, so let's start. Okay, first thing, and I showed you this, and I showed you the code, and we're not going to go deeply in this, but this is a point I'd like to mention. I showed you, like, where is it? Yeah. So really, we're saying, well, where does the LLM thing go? Here, right? But there is some code here. And if you want to say this system works, we need to know that parts of it, at least the parts that are not LLM, worked as well. Because if you think about it, this is we know it's not deterministic. You run it once, you run it twice, you won't get the same answer. But this is proper code. We expect, if we have tests for that, tests that repeatedly pass, we can trust this code. The whole point of automation is putting in place some kind of guardrails that tells you can trust this part. So if you have a bug, you won't need to check everything here. You say, well, this part I have tests for, this part I have tests for, and this is proper code. So we have tests, we rely on them saying, well, if there's a problem, the problem is probably here. Okay? And that means that we need to write unit tests. So remember I showed you the examples. Some of them, I'm not going to go into details, but you can look at two kinds of things: the parts that are part of the logic, which is the scaffolding, and you can use mocks here. You can see I'm using valid fake key. I'm not really going to the LLM for that. And if you put this input, you will get this output. And scaffolding is about the logic in the thing before or after the LLM. So the more you can access different parts that are testable and write tests for them with skipping the LLM or faking it or whatever, you can write better tests to check these parts and tell you that these parts work. Now, you're thinking, we're testers. This is like a developer's job. That's true. But let's take it from the other way. If you're not going to write tests because you're not developers, you expect the developers to write tests for that. And for them to write tests for that, the code needs to be built in a certain way. We call it testable. So what you expect is two things: the scaffolding, which is test the logic of this code and before and after it calls the LLM, and the plumbing, which is the integration parts. If I call it and it returns an error, what it does, error handling, stuff like that, you can get all kinds of things there. So that's one layer. We're looking at a holistic view of, is this working? Part of is this working is the developers telling you, yeah, we tested these parts, they work. Good. We're moving on to the next level. The first thing is what we call sanity test. So this hasn't changed. What is sanity test or smoke test? Sanity test or smoke test tell you that if this doesn't work, there's not much, there's not anything worth testing for, right? If this doesn't work, we don't need to go further. Go fix that. So we need to do this. What does a sanity look like? Well, we're still at the unit level or something like that, but we are, you can see, I'm actually going to the LLM. But I know that if I call it, I'm expecting in the result, because it returns text, right? I want API. I know the prompt asks for these parts. I want API explanation and happy path and unhappy path and edge cases to be there. If a response doesn't have this is not good enough. Like, we're shipping it back to the factory. The developers can take over it and fix it. Because if this doesn't work, there's not much. I'm not going to spend some time on working on that. If I use it for, you see I'm using here a get for user ID API. If the user and ID are not in the plan, this is not good enough like this. The lowest of the lowest of the lowest part of the quality says this has to be there. You can also do things I did here, which is like a performance, and I did that also. This is like the logic plus LLM, while this thing is the controller plus like the whole thing. It's not just functionally, if it's something in there. Maybe you can say that this has to be like this fast. If it's not this fast, it's not good enough. You can define all kinds of good enough. We're going to show as we go on, but the sanity part is the lowest of the lowest form. If it doesn't work, we're not actually moving forward with our tests. And this has an impact on actual money, right? If you run these tests in CI, they will cost you money, tokens. So you want to stop as early as possible, like regular tests. Okay, so we got this. Now let's talk really semantic. How can we tell if this is a good answer? Because everything, the parts are working probably. Okay, and we passed the sanity test. And what I'm showing you here is the beginning of the beginning of the beginning. You'll need to write a whole suite of sanity tests and unit tests and whatever. Okay, because you want to shrink wrap your application around the chatbot with enough layers that you can say, okay, now we can actually focus on the answers. Okay. So I showed you an example of what's going on. This is like an elaborate thing, okay? Lots of text. And this is for get user ID, and you get, this is the explanation, and these are the cases, valid user ID return, user data and response content is JSON, and invalid ID. And if I gave it to you and ask you, well, is this a good API test plan for get user ID? And some of you will say, oh, this is okay. And so some things are missing here. Okay, so remember, this is where iteration comes in. And you can say, well, maybe 2 is not enough for a good plan. Maybe 3 is good. And if you run it again, you'll see that you'll have 3 happy paths, but 2 unhappy paths because this changes. So you need to define, this is like our job. We need to define what is a good result for this, okay? And the way to do this is try to write examples of that. So we call these golden datasets. And this is like a very minimal dataset. So it's like a basis for a scorecard. So initial golden set says it has to have an API explanation. And this is like completely human, okay? It can be completely comparable to what we get from the computer, but it's also something that one can look at and say, this is okay, because the first thing that we'll check is not to write tests for that, because they will break. We need to define. Defining is still a human thing. So we have sections, and in API explanation, we have this endpoint retrieves single user profile information. You can give your interpretation what this is. It could be exact. It could be examples. It could be like whatever. Happy path, retrieve an existing user ID. This, for this example, says that if my happy path my happy path section has to be there, and has to have at least an example about retrieve an existing user with a valid ID, like the happy path, right? If my plan that comes back from my bot doesn't have this, this is not good enough. This is a failure. Unhappy path, this has to be like, you can define your own qualification. It could be like, it has to have at least these 2, or it has to have one of these 2. So you define what is working for you, what is good enough. This is what we're actually working on. So once you have this, you can actually, in some way, I'll show you a more elaborate one in a minute, you can score it. This is what a score looks like. So you can say that for this endpoint, and you see there's a date here. I'll show you, when you run it, you expect this. The output had the explanation, which is correct. The happy path was good. This section was okay. Explanation, you gave a rating, subjective, of course, because we're human. And you give it, and you probably get an average score or something, which is okay. You give it a score. And you have more and more and more lines here the more you run it. And you kind of create a baseline of what you expect. Okay, and if this average score is good enough, it's ready to go. If it's not good enough, we need to tweak the system more. Okay, so that's nice. Let's say, short example here, we define something that will go through the story in a minute, but we want to verify the response doesn't have PII, emails, passwords, stuff like that. If you run the same result through a new golden data set, this is like a new requirement, right? If you run the same thing that we did, we'll discover that the score goes down, right? Because test case diversity is no longer good enough because it doesn't have anything that we expect it to have. And then we pass it along to the developers to fix it. Okay, let's go through a story like this. Oh, before we do, some of this you can automate. So, for example, I already showed you these are automatic tests that run through the agent. It, for example, check that as a response for a get user ID, I don't get any delete, post, or update. Again, you can say it's a Sanity thing, but Sanity is more like systemic. This is per API. It really doesn't matter where you actually put it. And it categorized like the order of the things, the structure. You can check that. So this checks that the happy path, you can see, the happy path is over above the unhappy path, and the unhappy path is above the invalid, like the edge cases. So you can define things that for the structures, things are there, context. We're getting like, we're building the layers of what is good and what is not good enough. Okay, so let's say that, remember, this is the original prompt. We want it this way. And now we have like the product manager comes in, he has an idea that you write this developer, and the developer fixes the prompt and says, to make the test plan more practical, you must include concrete example values in your test cases. Makes sense. We want examples in a plan. You run this and you get this, which is a bug. Okay, you get this. Sections are there, but this like credit card idea here, not good. Okay, so that's a bug. We want to fix the bug. How do we fix the bugs? We write tests for them, right? So we write tests like this is something that makes sure this is a mock thing, like a unit test, that says that we don't expect this to be here. And this is an integrated test that says we don't want to find something that looks like a credit card. This is the whole regex here inside it. And then you go fix the code. You go fix it. How do you fix it? Well, this is an updated prompt with this section here. This is the one that's being sent to our bot. Before generating the plan, you must identify if the API deals with PII, the personal identification information, like name, email, address. If you identify, you must not include real-looking examples of that sensitive data in your test plan. So we expect the results not to have this part here. Have we fixed the bug? Well, it depends on how you ask. You probably didn't fix the bug because a bug fixed means you don't want to see it ever again. This is not the case with prompts. We know that the whole session is about things that we can't control. And these are things that come from LLMs. And they can treat your prompt as a suggestion the way it treated it before. It's open for interpretation. So is that really fixing a bug? No, it's a start of fixing a bug. You probably need to put something in the code as well. We're not going to talk about this today, but I want you to remember that fixing bugs in prompts may work. That works. Okay, so we have this new thing, and let's say we did fix it. But before we did, what I gave you are like the developer stuff, right? How to fix a bug, write a test for it. Let's talk about semantically. How do we know that systemically things have gone better? We have this here, like this is the bug report, right? So we want to qualify this in a golden set, in a quality scorecard. So if this happens, it may happen. Remember, we fixed a bug, but we fixed it with a prompt. It will get a lower score, right? So this is more elaborate, more detailed golden data set with examples and say, this is, I expect these examples to be here and the quality score is here. And a new golden data set, because there's a new requirement, don't show us any PII, right? So we added this. The response should not contain sensitive, non-public user data. And that means that, again, this is like instructions for the reader. This is manual, completely human. And you can see that the scorecard, which is also updated, we want in the AI output to have things that are, you see, security stuff. Where is it? We're not there yet. I'll show you in a second. And you get a scorecard. I missed that. Okay, good. Rewind a bit. Not only that we had this, we also wanted to add security things here. So this is an example of the before. This is an example of the after. We want these things, plus we want this section as well, security, privacy. And if we do that, yes, we expect this, but security cases for our result, it doesn't have any, right? This doesn't exist here. So we get a lower score. Same result with new types of classes, right? And how do you fix that? First of all, you can also automate the scorecard. You said that in our example, I want to make sure that we have things, details, words like security, privacy, PII, masking, because these are parts of the things. Of course, it can be a lot more specific than that. If it doesn't have any of those, this is not a good plan. It was like 2 days ago, but now it's not. So if you're going to fix things with a prompt, you will add this critical safety instruction for generating plain must identify the API. We know this, that's the PII, but also this thing part. This is new part, security and privacy. We want this to have that. Okay, will this work? It does work most of the time. Yeah. So when you do this again, you run it, you get something with security, you get back to something like include security, scorecard, showing you the score again. Okay, so you see, like these are like things that we've done this before. Like we think, we define what's good enough. We always define what's good enough. We didn't just define good, but it was easy to think about assertions as pass-fail. This is no longer the truth, and so we need some fuzzy things here. So we use a golden data set, examples of what we expect to have here. And they're subjective. Some of that we can automate. And then there's something new going in. Say, we want this too. Let's add that. 5 more minutes. Okay, I'm going to show you a couple more things. So this is an iterative thing. You think about more things, more subjects, more ideas. This is the planning part, and it goes through, and you said, this is more, it requires more testing, more unit tests, more system tests, more golden data set as examples of what we expect, and quality score. Okay, but this is, I would say, well, this is enough, but this is like snapshots, right? When you look at around, you say, is this good enough? Yeah. Is this going to be good enough tomorrow? Maybe. What does it mean that if you run it this for a week and you get like scores like between, I don't know, 9 and 11? Is this good enough? Okay, we know that things are going to change. We know we don't expect a full score every time. We need to define what is good over time. And we know that because we read the news, but we don't see it every day while talking to chatbots. But we know that models are changing all the time. We can run the same prompt with different models. That's up to us. But also, within models, things are changing over time, like over the day, right?
Hi, Gil.
Yes? We have
I'm
4 minutes.
really sorry to cut you here, but gentle reminder that we have 9 minutes left, and we would also like to take few Q&As. We have got Q&As, so
So I'm going
please.
to finish, okay?
Okay, thank you so
Very
much.
quickly. So
Yeah.
first of all, you need to think about this not as a snapshot, like you need to look at trends, and you need to think about more stuff. I'm going to go back to my slides. Like we talked about bugs, new requirements, cost, tokens. You need to understand what's it costing you and run things differently. Attacks, I didn't show examples, but what happens if somebody sends a prompt, like hijacking your prompts? Uh, this requires more and more things and more things. And I haven't shown you this, which is the AI judge. Sometimes you decide to, at the end, ask a stronger model what it would say or how it would evaluate your response. So this is like what testing was before, but like expanded. AI did this. It exploded everything. It's still what we did before, but we need to think on a wider space, on like a lot more. And before I finish, I'm doing a webinar on the risks of AI-generated code and what it means to testers on September 16th. This is where you want to go. And if you want to register, really recommend it. I'm going to talk about things like that and how you understand it, what it means to testers. But to finish off, one last section. People think that AI is going to replace testers. The way I see it is that testers are becoming a lot more proficient in understanding what are the risks are, what's going to happen, and how it impacts our job. And like I said, we need to be a lot more, we used to think about like manual testing, automation testing. I think this is like things from the past, but we need to become like quality architects. We need to understand quality, what it means, and we're defining new ways, we're learning to define new ways of how to evaluate what is good enough. And if you do this for a while, you can actually trust your chatbots. And I'm finished, so thank you very much. And if there are questions, that would be good.
Yes, yes. Thank you so much, Gil. This was a wonderful session. We have few questions already lined up. I am going to present it on screen, and you can just answer these. We
So
have our first question by Paul.
yeah,
He has asked,
yeah, this is very confusing. I'm going to stop sharing.
okay, okay. Let me know if you could see the question on the screen. The question is,
um, the Q&A. Oh,
yes,
okay. Tell me about
yes,
it. Yeah.
yes. So we have a question by Paul. What's the best approach to test a chatbot against prompt injection and jailbreak attacks?
Oh. So, first of all, prompt injection is where this is what I mentioned about somebody sending in some text that try to hijack the system in different way. And I'm going to answer it from the testing perspective. How do you even think about these things, because usually that's not what we do, right? Security and stuff like that used to be like something that the company brought in like as experts, and they would think. Now it's our job to think about this thing. The solution is first to think about what can happen, understand how the system is working, how it's built, and then put the guardrails in so it won't happen. So for example, I have in my examples in my repo, which will be somewhere, and it's on GitHub. You can look at it. There's you can hijack this for a pirate joke. So instead of a test plan, you will get a joke. How do you do that? Well, you think about, first of all, what can happen. And what can happen is somebody taking control. So in my case, it will be that something, at least I expect that if something like this happen, I will try to identify it. How will I know? This is like a discussion we need to have. How do you identify this? Look for words in the prompt, clean them up before they're going into the LLM. Make sure that what you got in the agent itself, and after that in the chatbot, is something that you can present in terms of safety, in terms of bias, whatever. So there's a lot of layers here of understanding. First, the new surface of attack, what it can do, understand how the system is built, and therefore where to put the guardrails, and how to test for it. Because if you're thinking about pirate jokes and other stuff, you can test how the system works for a pirate joke. But if you don't think about pirate jokes, you don't even think about attacking like prompt injection or history parsing. If you don't understand this, you don't know about this, you will not test for that. So when I said we need to think wider than we usually do, this is the part we need to understand that systems have become a lot more complex, and in this case, a lot more. There's a lot more surface for attacks, and we need to understand these attacks in order to first foresee what they do and then how to solve this. So this is a very good question, but requires like 30 minutes of answer. So this is one short.
I agree to that. And thank you so much for answering that question. We have another question by Pawan Kumar, and I will bring this up on screen. Which parts of an agentic system should be deterministic to make failure reproducible?
Ooh, every part of it. I was working on my special. I have a special project when I tried to teach my agent. It was Claude to do TDD, test ready development, which meant that it ran created the test first, failed, and then write the code for it. It worked most of the time. Like it was a prompt, but sometimes it skipped and it apologized, which is very nice of him, but it didn't do what I needed. So if you need to identify what are the things that you don't allow to be wrong. And you have to rip these things out, and they either have to be deterministic or put guardrails around them, like that they will become more deterministic. But it's more about you deciding what is not allowed to be not repeatable. Everything, like I started at the beginning, like what our brains is doing when we're looking at results of a chatbot is this is okay because we're used to it. We understand usually what's right, what's wrong, and go and try to identify those. And we cannot ignore what is wrong because obviously it's wrong. An agent cannot do this. We need to tell it what is wrong. And if we can't do this, and there's a chance that things will change over time because these are prompts. This is the new programming language. It's not going to be deterministic. And this is why I mentioned bug fixes inside prompts are not going to be reproducible as well. We can hope, but this is not our job to hope. So this is like a very big design question. We need to say, well, this part of the system needs to be running this way every time, and if something is wrong, we need to know about it, and we need to be able to reproduce it. not hunt things from the logs. And this is like a very big design question. How much of the system is going needs to be deterministic, or deterministic as we want it to be? Um, for testers, the answer is that we need to know how the system is built in terms of testability. What do the test results mean to us? Because if you're like treating the system as a black box and it's got moving parts inside it, we won't understand what red or green means, because we run it again, we get a different answer. We need to know how things are working, what is the deterministic part, what is not the deterministic part. Like again, 30 minutes, 40 minutes of talk just about this.
Exactly. Yes, yes. Thank you so much, Gil. That was a wonderful session, and we really enjoyed it. And for others who are currently viewing our session, thank you so much for joining. Concrete techniques for testing text that is never the same twice are exactly what most teams are missing right now. Let's continue the conversation on social media. Don't forget to tag us and share learning from this session using hashtag TestMuConference. Also, all the sessions will be available on YouTube channels, so you can revisit them anytime and share them with your peers. Before we move on to the next session, don't forget to explore our partner booths to connect and exchange ideas. You can also participate in the contests that we have lined up for you. Please visit our participate webpage. It's in the chat box. Happy testing and enjoy the rest of the conference.